Hello. Today is all about graphing. It's about remembering your parent graphs, how they move, rational functions, and how we deal with those. So what I would like you to do right now is actually pause this video and do those first 6 graphs on your thing. Download Desmos, type them in, see what they do, and see if you can answer the questions. After that, open this up and let's go. All right. When you download a Desmos and you type these in, the first 3 are parent graphs, or actually the first 5. So, oh, I grabbed an absolute value instead of x equals. Here we go. Let's change that. So y equals x is a straight line. I'm hoping you remember, you look at the degree, you look at the highest exponent here. So this degree is 1. Even or odd is when you typed in the negative x. So f of negative x equals negative x in this case. So it's absolutely opposite. So it's odd. And the degree tells you how many roots, and this time it crossed the x-axis once, so we have 1 root. You should have noticed that the x squared and the x to the 4th were almost identical. It just flattened out here on the x to the 4th. So when you look at here, you had degree 2 and degree 4. Even or odd, no matter which one you plug it into, you will get the same thing back, and we'll just do the f squared. So if you do x negative x equals negative x squared, you still get x squared. So since it is identical, both of these are even. Now, real roots. It looks like there's 1 because it only crosses here, and technically that's true. There's only 1 root. It just has a multiplicity, so that means this 0 actually counts twice here. So technically there are 2, and the 2 real roots are 0. It just has to be 0 twice. The same thing as here. There's 4, it's just that the zeros are 4 times. It's called multiplicity, if you remember from last year. Okay, x cubed and x to the 5th. Again, it flattened out here when you drew it in. You should have had 3 and 5. Plugged in your negative x. And you got negative x cubed, completely opposite. So both of these are odd. And again, real roots, there's technically 3 and 5. With a multiplicity, this guy has 3 zeros, and this guy has 5 zeros. All right, let's go down here. How did you do on these? These were your transformations. I expected you to remember that plus 3 moved the whole thing left 3. So you went left 3 and drew in your graph. The degree is still 4. But this time when you do f of negative x, you get negative x plus 3 to the 4th. It is not the same and it is not opposite, so therefore it is neither. Either, wow, that looks terrible. Let's see if we can write it over to the side over here better. So this one is neither. Let's try that again. That's a little better. And how many real roots do you have? Technically, again, there's 4, but they are all 4 negative 3. So if you put down 1 negative 3, I probably would not count that against you because that is technically correct. There's 1 negative 3 has a multiplicity of 4. All right, this guy's a little different. X to the 4th minus 5. Okay, so your degree is 4 again. When you type in the negative this time, f of negative x, you get negative x to the 4th minus 5, which gives you x to the 4th minus 5. Since it is the same, it is even. No, it looks a little weird, right? Since it's even, now how many real roots do I have? I have 2. All right, so I have 2 real because it crosses the x-axis twice. So I have 2 real. Do you remember what the other 2 are? I'm hoping you remember they were 2 imaginary. All right, this guy is 5. Okay, again, so we know our degree is 5. This time when you type in your negative x, you get 2 times negative x minus, 3 to the 5th plus 1. It did not all change. It did not all stay the same. So again, this one is neither. And he has 1 real root. He only crosses the x-axis once. It's not a turning point, so it counts once. And the other 4 are imaginary. I hope you did well. All right, let's continue on. All right, use Desmos and graph these, please. Okay, when you graphed, I wanted you to notice a couple of things. So again, our degree is 3. We learned that from the first term. If I plug in a negative, the first term turns to a negative, the second one stays. So I end up with negative 8x cubed, end up with a negative 12x squared, and I can be done because one changed, one stayed the same, so it is neither. Real roots, it crossed the x-axis 3 times. Since there's only a possible total of 3, I have no imaginary. All right, so this one here has degree of 4. When you plug in your negative, the first one stays, right? So that's negative x to the 4th, but the second one changes. So since it's neither the same or either, it's neither even nor odd. Now when you look at this one, it crossed, if you had to zoom way out, I know my numbers are off, this one into the hundreds, but you have it crossing 2 times, so you have 2 real, which means you have 2 imaginary. And they're down here. I hope you did a good job. All right, next one. Looking at the graph, all right, I know you cannot tell me exactly what degree these are. I want to know the lowest degree it could possibly be. So when you look at this, it's like, how many times could it cross a horizontal line? And the most this one has is 3. So we put down 3. All right, it has 3 real because it crosses the x-axis 3 times. That means there's no imaginary. And since it ends positive, my leading coefficient is positive. Remember, if it ends negative, then it's negative. Okay, pause and do yours. Again, this degree was 3. This time we only have 1 real root, which means I have 2 imaginary, and its leading coefficient is negative since it ends down. This one, if you looked here, and we draw this horizontal line, it can cross 1, 2, 3, 4, 5, 6 times. So its degree is 6. It has 4 real, see, 1, 2, 3, 4, which means it has 2 imaginary, and it ended positive, so leading coefficient is positive. Just a quick review of last year. And I think algebra 2, if I remember right. Okay, numerator is larger than the denominator, so we're looking for different ways that we can cancel our slants and our asymptotes is what we're looking for here. So the first one is a whole. We haven't done a lot of those. So when I look here, I have x squared is greater than x. I look at the leading coefficients. So I'm looking at, or the leading terms, I'm sorry, x squared over x. This guy is larger. All right, if that happens, we set the denominator equal to 0. And that gives us x plus 1 equals 0. So we know x is negative 1. So at negative 1, so if I was doing this, I would draw a dashed line at negative 1 because I know this is where it's undefined. So x cannot be equal to negative 1. So this is either currently an asymptote or a whole. Next, we factor the numerator, and we get x plus 1, x plus 2, over the denominator, which is x plus 1. Well, if it cancels, I am taking it out of the graph. Since I am taking it out, that will be a whole. I am left with y equals x plus 2, which is a line. So we go to our y-intercept of 2, up 1 over 1. We draw our graph at negative 1, where my dashed line is. That's not technically part of the graph. I put a hole in the line. So this equation can equal anything up to x equals negative 1 and anything past x equals negative 1. All right, case 2 is they're identical. I love these kind because they're so much fun. Okay, vertical is always the same. You take the denominator and you set it equal to 0. So I do this, and x cannot be equal to negative 2. So I'm going to put that on my graph so I don't forget. So it is either an asymptote or it's a whole. Okay, so next I look at this, it's not going to factor, but to find my horizontal asymptote, I actually create an H for horizontal. I put the leading term of the numerator in the top and the leading term of the denominator in the bottom of the H. We reduce it, and 3/2 or 1.5 is my horizontal. So I'm going to put this on here. So far my asymptotes are x equals 2, and y equals 3/2. Now I've divided my graph into 4 sections, right? Here's 1, 2, 3, 4. So I've divided it by the asymptotes. I have to figure out where my graph is. To do this, I just type in a number to the left and to the right of the asymptote. I can get to my graph here. So I have -2, so I'm going to put -1 into my original and -3 into my original. Now that I'm on the right side of the graph over here, all I want to know is it top or bottom, and I can sketch that in. You only need to graph 1 point. I don't want exact graphs. So we take -1, we plug it into our original. So we're doing 3 times -1 plus 2 over 2 times -1 plus 4. So we have -3 plus 2, which is -1, -2 plus 4, which is 2, so -1/2. So at -1, I'm at -1/2. So you're going to take that. Since this is below the asymptote, I can now sketch this in. Let's stay on there again. So we sketch up to the asymptote. We approach but do not touch on this one. And the same goes here. Now I do on the other side. So I take the -3, again plugging it up here. So we have -3 times 3 plus 2 over 2. I typed that in backwards. Sorry about that. Make that look at least right for you. Maybe. There it goes. All right, so it's 3 times -3. I know it was the same thing, but I wanted it written right. Over 2 times -3 plus 4. So we have -9 plus 2, which is -7. -6 plus 4, which is -2. This is a positive, so a positive 3.5. So I go -3 up to 3.5. And now that's above the asymptote. So I approach, but do not touch. And that's graph. That's a rational expression. Case 3 is the degree, numerator is 1 degree larger than the numerator or the denominator. It creates a slant. All right, we will be doing that, but not at this time. So just now know you have a slant, and we'll worry about that later after we learn long division. So pause and do these two. Okay, first one, they were the same. So your first step always is your vertical. So we take x minus 3, set it equal to 0, and you should have gotten x equals 3. So we go to x equals 3, and we put in our vertical. So x equals 3, vertical asymptote. Next, so horizontal is second. So we draw our h, put in our 4x from the numerator, our x from the denominator, and we get 4. So we go to 4 and draw in our horizontal. Next, we plug in 1 point from each side. So since I'm at 3, I'm going to plug in a 2 and a 4 back into the original. So let's go over here. 4 times 2 minus 6 over 2 minus 3. So we have 8 minus 6, which is 2 over -1, or -2. So 2, -2 is here. Now make sure you're approaching the asymptote and not the x-axis. So we have that half done. Now we have to do the 4. So we do 4 times 4 minus 6 over 4 minus 3. So we got 16 minus 6. So we've got 10 over 1, which is 10. So we go to 4 and 10, which is a little bit off my graph. Again, draw in, approach your asymptotes, but do not touch. And that one was done. All right, this one. Now, if the denominator is 1 degree less than the numerator, our horizontal is 0. But first step is always vertical. So x plus 3 equals 0. So x equals -3 is my vertical asymptote. We got x equals -3. So the horizontal, you should have started off like this and made your x, and you put a -2 over x. Since x is in the denominator, the answer is 0 because it can't be 0. It's undefined there. So then my horizontal is just the y-axis, or the x-axis, sorry. Next, we plug in 1 on each side. So since we have -3, we're going to type in a -2 and a -4. You can pick anything you want. Those are just the ones I like. So we're going to do -4 first. -2 over -4 plus 3. -2 over -1, or that's a 1, or +2. So we go to -4, 2. There's my thing. We draw and approach, but not touch. Type in the -2 next. So now we have -2, -2 plus 3, -2 over 1, or -2. So -2 is down here. Again, approach, but do not touch. I hope you did well. And good luck with your homework. Remember to post on the discussion board if you have questions.